Hello everyone. Today I am discussing about the important chapter of emulsion. Emulsion is very important chapter for the dosage form. There is a biphasic liquid dosage form. That means two phases are already present, and emulsion is a biphasic immiscible liquid dosage form. Biphasic means two phase. Oil and water, they are not miscible. That's why these are the immiscible liquids. So in this case the emulsification agent is used to miscible the emulsion. So today I am discussing about the important questions of emulsion. There are some important questions are very important for the semester purpose. So everyone please follow this question and answer also. So first of all, first question is what affect the stability of the emulsion. That means which type of effects are very much important for the stability of the emulsion. Emulsions are thermodynamically unstable and they are stabilized by adding emulsifying agents, and the emulsions should exhibit physical and chemical stability during storage. And if the emulsion doesn't exhibit any creaming, cracking and phase inversion during the storage, then it is said to be a stable emulsion, and they may cause instability of the emulsion caused by creaming, cracking and phase inversion. That means when after preparation of the emulsion, when you will stable the emulsion, then three effects are very important: creaming, cracking and phase inversion. Because these three factors are very much important, because these are used because due to this problem, creaming, cracking and phase inversion, the emulsion may be unstable. Okay, so what do you mean creaming? Creaming is defined as a upward or downward movement of globules to form a thick layer at the surface of the bottom. That means the surface or the bottom part in the emulsion, then one type of thick layer is created, and that is called a creaming. And upward creaming and downward creaming, there are two parts of the creamings are available: upward and downward creaming. Upward, it forms the thick layer at the surface emulsion and occurs in the oil in water type of emulsion. But downward creaming, in this case the water in oil type of emulsion is created, and it is also thick layer, and it is the bottom layer of the emulsion. Okay, that means when the upward layer of the emulsion is thick, then that is the called upward creaming, and the bottom, when the bottom part of the emulsion will be thick, that means the downward creaming will be formed. The Stokes law, it is used to determine the stability of the emulsion. This is the formula. So everyone please follow this formula, everything is here. So this Stokes law explains the creaming of emulsion. That means it is used for the determination of the stability of emulsion. Okay, and another function of the Stokes law is it is used to determine the sedimentation also. Okay, so this is important, this is a very important question. Another part is factors. Which type of factors are very effective for the creaming? Viscosity. Low viscosity increases the rate of creaming size. Globules, difference between the density of dispersed phase and continuous phase also, and gravity also. And what do you mean cracking? Two or more globules combined with each other to form a large globules. Okay, which will cause the complete separation of two layers, that is the aqueous phase and the oil phase, and redispersion is different on the second, that is a cracking, and this cracking is caused by addition of a opposite type of emulsifier, precipitation or degradation of emulsifier, and addition of a common solvent, microbial contamination, temperature changes, etc. And another point is a phase inversion. Phase inversion, when the two phases are totally separated in the emulsion, that means oil phase and water phase, that is called a phase inversion. Okay, and phase inversion caused by changes in phase volume ratio, changes in temperature, cracking also, storage period, and changes in nature of the emulsifier. Emulsifier means emulsifying agent. So in the emulsion, the function of the emulsifying agent is very important. Okay, and it plays a very important role, that is called a phase inversion. And another question is, which type of emulsion is very stable? Emulsions that have a smaller size droplets and will generally be more stable. For water separation, drops must coalesce, and the smaller the drops, the greater time to separate. The droplet size distribution affects emulsion viscosity because it is a higher when the droplets are smaller. Okay, and the next question is, how can you increase the stability of the emulsion? And already I have discussed the stability, which type of factors are very important to improve the stability of emulsion. So first of all, you have to avoid this type of factors. Okay, and the factors that influence the stability of emulsion include the lowering of interfacial energy and the strength of interfacial film and lowering of interfacial energy, etc. How long can an emulsion remain stable? Droplets of water dispersed in oil. Okay, and 3 years. Time will be 3 years. What is the difference between a stable and unstable emulsion? What is the stable and unstable? Already I have told that. And what are the two factors that are destabilized the emulsion? That means cracking, creaming, phase inversion. Another factor, pH, ionic strength, temperature, nature of biopolymer and medium, presence of other agents, etc. Okay, and next question is, what makes an emulsion stable? What makes an emulsion stable from a thermodynamic point of view? And emulsion is an unstable system and to separate and reduce its interfacial energy. Emulsifier stability can be defined as a system ability to resist changes in its physiochemical properties over time. Okay, and another question is, how does pH affect emulsion stability? That means, what is the important part? The pH effect on the emulsion stability is usually attributed to ionization of polar groups of surface active comets, which induce sufficient electrostatic repulsive interactions to break down the interfacial film cohesion. Why emulsion is thermodynamically unstable? Because from a purely thermodynamic point of view, an emulsion is an unstable system because there is a natural tendency for a liquid-liquid system to separate and reduce its interfacial area and hence its interfacial energy. Okay, and does emulsion have a shelf life? Diazoemulsion have approximately 1 year shelf life. And what causes an emulsion? Actually, emulsion is from two immiscible liquids, oil and water, and that's why emulsification agent is used to miscible the emulsion. There are two phases, continuous phase and dispersed phase. When the oil is dispersed into the water, that means water is continuous phase. When the water is dispersed into the oil, that means the oil is continuous phase. Okay, next question is, why emulsion is very important? Because emulsion is a very much one type of dosage form. Okay, semi-solid biphasic liquid dosage form, and emulsions are useful because they allow ways to deliver the active ingredients, that means drug, in water, and which is inexpensive. Okay, and inexpensive. A related advantage of emulsions is they allow dilution of these active ingredients to an optimal concentration. What is an example of emulsion? Okay, there are different type of examples are also important. So classic example of an emulsion is oil and water when mixed slowly under the vigorous stirring. However, when the agitation is stopped, the two liquids separate, emulsion breaks down. What are the types of emulsion? Oil in water, water in oil type of emulsion. How do you break the emulsion? Cracking, creaming, phase inversion, these are. And what are the characteristics of emulsion? While water and its intransparent emulsions are usually maybe designed to have a pulsate and appearance, and while water and oil are thin, free flowing liquids, emulsions can be made as a thick creams which don't flow. Why emulsion is a thermodynamically stable? Microemulsion is thermodynamically stable and it gives free energy caused by some effects What is the emulsifier? Means emulsifying agent. What increases the viscosity of emulsion? The viscosity of the continuous phase is increased by solution of solubilizer and continuous phase of oil in water emulsions. Okay. Another question is, how do you make oil water emulsion? Two phases heated by water bath at 75 degrees centigrade. As the emulsifier melts, stop heating and slowly add the oil phase to the water phase while blending the water phase, and blend glycerin and gum in a small beaker and add this to the emulsions. What is the best natural emulsifier? Beeswax. And what is an example of the oil in water? Milk. So milk is a one type of oil in water emulsion. What is the nano emulsion? Nano emulsions are nano sized emulsion. That means these emulsions depends on the size of the particles. What is the difference between emulsion and micro-emulsion? Already I have told emulsion. It is a bi-phasic liquid dosage form. There are two phases, bi-phasic immiscible liquid, oil and water. That's why emulsifying agents should be used to miscible. And micro-emulsion means the particles, the microparticles, the small size of particles may not dispersed into the emulsion. That is called the micro-emulsion. And micro-emulsions, on the other hand, are thermodynamically stable. How does temperature affect emulsion? Affect stability of the emulsion. It very much stable due to the presence of temperature. Most important effect of temperature is on the viscosity of emulsion, because viscosity decreases with increasing temperature, and temperature increases the thermal energy of the droplets and therefore increase the frequency of drop collision. And another question is, what are the disadvantages of the emulsion? Different type of disadvantages are available. Emulsions are thermodynamically unstable. Proper selection emulsifying agent leads to phase inversion, and sometimes it may also lead to cracking. How do you prevent the phase inversion in emulsion? To prevent phase separation in cause where the phase densities cannot be changed, it is common to increase the viscosity of the emulsions either by dissolving thickeners in the continuous phase or formulating the emulsions with a high packing itself. And why do oil droplets in water? The coloring oil droplets will have the some surface change. Charge, a repulsive force develops between the droplet during the collision. What are the advantages of the viscosity of the polymer emulsions is much lower than the straight polymer in the melt phase. Okay. And another question is, what are the application of colored? Colored is used thickening agent, and it is industrial products such as lubricants, lotions. And what is a multiple emulsion? Multiple emulsions are complex systems where both oil in water and water in oil emulsion exist simultaneously, which are stabilized by surfactant respectively. And what is the micro-emulsion method? Already I have told previous my video. How do you make the nano emulsion? It is also depends on the size of the emulsion particles. How does emulsion polymerization work? Emulsion polymerization is a polymerization process, and with the different applications on the industrial and academic scale. It involves application of emulsifier to emulsify hydrophobic polymers through aqueous phase by amphoric emulsifier. And what is the droplet size? Droplet sizes are measured in microns. A micron is 1 by 1000 micrometer, or about 1 by 25,000 of an inch. How much a droplet size? 0.05 in the 20 drops per milliliter. Why are water droplet round? Surface tension is responsible for the shape of liquid droplet, and although easily formed droplets of water tend to be pulled into the spherical shape. What is the primary emulsion? Actually, in a primary emulsion, the globules inside emulsion consists of only a substance or phase, and that is the droplets of oil inside water or water droplets and which inside all over the primary emulsion. What is the secondary emulsion? In secondary emulsion, the globules inside emulsions consist of two phases. Each droplet consists of a globule encapsulated within another globule. For example, there is an oil drop on which there is a water drop surrounding it. What is particle size of the nano emulsion? 100 to 500 nanometer. This is very important part, okay? Another question is what are the components of emulsion? What are oil surfactant? And what are the properties of emulsion? Emulsions are colloidal in which both the dispersed phase and the dispersed medium are liquids, while the mixture of water are the emulsions when are the second together. Which types of factors are influencing stability of emulsion? Temperature, light, pH, oxidation. How does pH affect emulsion stability? The pH affect the emulsion stability is usually attributed to ionization of polar groups of surface active components to break down the interfacial film cohesion. Another question is how do you evaluate emulsion? This is very important. There are two types of evaluation methods: physical parameters and chemical parameters. In the physical parameter, phase separation, viscosity or rheology studies are included. Electrophoretic properties, particle size analysis and particle count also included, but this is the physical parameter. So what is the phase separation? Phase separation, it is not been described in literature. That means there are two phases, biphase oil and water, totally separated, and the amount of the cohesion observed at room temperature depends on the concentration of the emulsifier. Visible correlation occurs after 1 month only, and visible correlation is negligible after 2 years. Next, viscosity. Viscosity is very important for the emulsion. Emulsions are non-Newtonian fluid. The various viscometers used for the determination of the viscosity for study life studies and emulsions changes in viscosity during aging, but not absolute viscosity are very important. Okay, book filled viscometer is used for the determination of the gel. Generally, viscosity is determined by the Ostwald viscometer, but in the gel preparation, the book filled viscometer is very important. Electrophoretic properties. Electrophoretic method, first method, and micro electrophoresis apparatus critical value of the zeta potential 20 to 15. Electrical conductivity apparatus amperometer. Okay, and particle size analysis or particle count, electronic counting method, just like a culture counter, and light scattering related replays. Light scattering and related reflectance, the charge of the reflectance and the wavelength at which the colored internal phase partially absorbs at the incident light has been found to be inversely proportional. And evaluation, emulsion stabilizer, kinetic emulsion, the oil in water emulsion. Okay, another part is physical test. Change in electrical conductivity, high reflection, viscosity, particle size, chemical composition, etc. Another question is how do you preserve the emulsion? Microbial contamination may occur due to contamination during development or production of emulsion or during its uses of impure raw materials and poor sanitization conditions. Okay, so this is the preservation of the emulsion. Next question, precaution to prevent microbial growth. There are some important points are very important. Use of uncontaminated raw materials, careful cleaning of equipment with stain. Contamination due to the microorganisms can result in problems, color, odor change. Therefore, it is necessary that emulsified system. And what is the emulsifying agent in milk casing? That means casein is a one type of emulsifying agent which is present in milk. Classification of emulsion: oil in water, water in oil, etc. And another question is, how do emulsifier work? That means the function of the emulsifying agent you have to write. Ideal properties. Ideal properties of the emulsifying agent very important. Should reduce the interfacial tension between aqueous and oil phase. Produce adequate viscosity, effective and less quantity, chemically and physically stable. It should be non-toxic in nature, and it should be inert, and it should not interfere with other ingredients used in emulsion preparation. Type: primary emulsifier, secondary emulsifier. Okay, so the function of the emulsifying agent is important because in the emulsion, the emulsifying agent is very important. And classification of emulsifier: natural, polysaccharide, example acacia, agar, pectin, starch. Sterol containing emulsifying agent, example beeswax, wool fat, wool alcohol. Semi-synthetic emulsifying agent, polysaccharide, methyl cellulose, example. And synthetic emulsifier, surfactant is example. Surfactant, there are three parts: anionic, cationic, non-ionic. Anionic, alkyl sulfate soaps. Cationic, cetrimide, benzalkonium chloride. Non-ionic, polyvinyl alcohol. Finely divided solids, bentonite, example miscellaneous carbamide. Example of primary emulsifying agent: Lessnin soap. And difference between the emulsifier and stabilizer. Emulsifier and stabilizer are both classified as additives, while emulsifier help to mix together substances which don't easily mix, such as the oil and water. Stabilizer, on the other hand, it is used with dessert consistency and stops this substance from the separating again after they have been mixed. Okay, this is the difference between emulsifier and stabilization. So today I have totally discussed the important question of the emulsion. These are very important from the emulsion chapter. Please everyone follow this question with answer, and I will give my notes on my video description part. So please everyone download these notes from this link. Okay, so this is very important because emulsion is a bi-phasic liquid dosage form and it is important for the pharmaceutic subject.